So I hope you have got these answers for cofactor of m. So cofactor of m will be this is your m, I think. No, this is S2, S3, S4. Then S2, S3, S4, S1, S1, S2, S3, S2, S3, S4, S3, S4, S5. So is this your cofactor of m? Please tell me. What is your cofactor of m? Is it correct? Please tell me. Have you got the answer of cofactor of m? Has anyone got the answer of cofactor of m? It is very simple. It will be simply what? Alpha 12. So for first element, first row, first column element, what is your, how to calculate the value of first element of the cofactor m? It is simply what? Multiplication of this matrix alpha 10, alpha 3, alpha 3, alpha 5, which is nothing but what? Alpha 15 plus alpha 6. Has anyone got the answer? Have you got the cofactor of m? At least cofactor of m. I don't expect m inverse from you, but at least cofactor of m is very simple. Cofactor of m is given by, if you are finding out the first element of the cofactor of m, that means first row, first column element, then you have to leave the first row and first column. And what is the remaining part? This is your remaining part. So alpha 10 into alpha 5, take the determinant of this matrix. So alpha 10 into alpha 5 and alpha 3 into alpha 3, that is alpha 6. So this is your first element of the cofactor. Have you got the answer? If not, please write this down. Write this down. So the next is what? Second column, first row element. Second column, first row element means what? Leave the first row and the second column as it is. So alpha 9 into alpha 5, that is alpha 14, and then alpha 10 into alpha 3, which is alpha 13. Okay, I hope you have got this correct. Just write down this. If you are having any trouble, any doubt for calculation of cofactor of m, please let me know. Please let me know what is your answer. Is it correct? Anshu, Parag, Ankita, Harsh, Kalyani, Priyak, Rohit, Srishti. Is it correct? Have you solved the cofactor of m? I hope you have got the answers for cofactor of m. If not, just write this down. Cofactor of m, and determinant of m is alpha 4. If you have not got the answer, just write this down. Just get this concept. If you are calculating, suppose the second row, third column element, that means you need to leave the second row and third column as it is. So you will have to take this element and this element for the matrix, determinant of matrix. So alpha 12 into alpha 3, that is alpha 15, and what is the remaining? Alpha 9 into alpha 10, so alpha 19. Okay, so this is your cofactor of m. Determinant of m is alpha 4. So determinant of m is, I have corrected the slide here. Determinant of m is alpha 4. This should be alpha 15. This should be what? Alpha 4. So this is your cofactor and determinant of m is alpha 4. Now you have to divide each and every element of cofactor. So divide each and every element by alpha 4. So this should be your m inverse. So what is m inverse? Alpha 13 by alpha 4 is alpha 9. Then alpha 2 by alpha 4, it will be 1 by alpha square. keep this as it is, 1 by alpha square. I will tell you how to take this alpha square in the numerator. Then alpha 14 by alpha 4, that is alpha 10. Alpha 2 by alpha 4, it is 1 by alpha square. This is 1 by alpha cube. This is 1 by alpha cube. Alpha 10, 1 by alpha cube. This is 1. Okay. Chalo, write this down. This is clear. If this is clear, please let me know. Have you write this? Have you written this M inverse in terms of this form? Okay. Now see, I need to take this alpha square. These terms. Look at these terms. 1 by alpha square, 1 by alpha square, 1 by alpha cube, 1 by alpha cube, and 1 by alpha cube. Okay. Now I need to take this alpha square and alpha cube values to the numerator. So how to take these values to the numerator? Now remember, I can replace this 1 by alpha 15. I can replace this 1 by alpha 15. Okay. If you are having any term in the denominator in terms of alpha, then you can do this. You can replace this 1 by alpha 15. So replace this 1 in each of these terms by alpha 15. So numerator will be, instead of 1, we are going to replace it by alpha 15 and then do the division. Okay, so I have replaced this 1 by alpha 15. So alpha 15, all these ones will be replaced by alpha 15. So this is alpha 15 and this 1 by alpha 15, and then take the division. So alpha 15 by alpha 2 is the thing, but what? Alpha 13. Similarly, alpha 15 by alpha cube will be what? Alpha 12. Okay. So write on this. Have you understood this step? Remember, replace this 1 by alpha 15 because I need to take this alpha square and alpha cube terms to the numerator. So I'm going to replace this 1 by alpha 15. Okay. So this is normal practice in each and every example where this one comes in the numerator and the alpha term in the denominator, then you can replace this 1 by alpha 15. So write this down. So what is your M inverse? This is your actual M inverse. I hope you are understanding this. So alpha 9, alpha 13, alpha 10, then alpha 13, alpha 12, alpha 12, alpha 10, alpha 12, and 1. So you don't have to replace 1 by alpha 15. Even if you replace that, it doesn't matter. You will get the same answer while solving the mu 3, mu 1, mu 2, and mu 1. Okay. So this is your M inverse. Okay. Have you written this M inverse? Please let me know. If you have written this M inverse, please let me know. Okay, done. Please write down this carefully, this step carefully. So next is, you will just replace M inverse by the actual inverse of that matrix M in the formula. So mu3, mu2, mu1 is equal to M inverse into S4, S5, S6. So that is alpha cube, alpha 5, alpha 5. And then you will solve this by taking the multiplication. So alpha 9 into alpha cube, that is alpha 12. Alpha 13 into alpha 5, that is alpha 18. Alpha 10 into alpha 5, alpha 15, which is 1. So tell me, what is mu3, mu2, mu1? I will wait for 5 minutes and tell me what is mu3, mu2, mu1. Okay? I'm waiting for your answer. Mu3, mu2, mu1. What is mu3? Alpha 5, alpha, and alpha 12. Okay. So mu3 is alpha 5, mu2 is alpha, and then alpha, mu1 is alpha 12. Okay. Correct. Remaining participant, write this down. Mu3 is alpha 5, mu2 is alpha 1, and mu1 is alpha 12. I hope you have got the answer. So 5, 1, 12. So what is your mu z? You will just replace mu3, mu2, the coefficients of z cube, z square, and z. So alpha 5 into z cube plus alpha into z square plus alpha 12 into z plus 1. Okay. So now see, the next procedure to find out the roots is different from the degree 2 polynomial. We have found the degree 2 polynomial by taking the such two roots where the multiplication is the coefficient of z square and the addition should be the coefficient of z. But here there are three coefficients, that is mu3, mu2, mu1, and the obviously inverse of these roots or zeros of mu z will give the error location. So your mu3, mu2, mu1, you will replace this. I hope this is clear. Then how to find the roots of this mu z? So this is the way to find out the roots of mu z having degree 3. You'll put z is equal to 0, 1, alpha, alpha square, step by step up to alpha 14 in mu z. And for any value of z, if mu z value comes as 0, then you will consider that value of that alpha in terms of alpha as a root of mu z. So this is lengthy procedure. So what is the process? How many elements there are in GF2 raised to 4? 14 elements, 16 elements are there. So we'll replace each and every element in the given mu z starting from 0, 1, alpha, then alpha square, alpha cube up to alpha 14. And for any three values of these elements, by replacing these values in mu z, you will have mu z is equal to 0. So for any three values where mu z comes as 0, that three values will be considered as the roots of mu z. Okay. So this is lengthy procedure. I don't want you to write. I don't want you to do this procedure right now. But after this session, try to find these values by putting each and every value of g of 2 raised to 4 elements. That is these values. That is 0, 1, alpha, alpha square up to alpha 14. Here I have solved the example. The values or for values of alpha square, your mu z comes as 0. Also for alpha 10 and alpha 13, your mu z comes as 0. I hope this is clear. Is this clear? Please let me know how to find the roots of degree 3 polynomial. Is this clear, or shall I tell you again? You replace value of z in mu z by putting all the values of g of 2 raised to 4 elements. Okay, starting from 0, 1 up to what, alpha 14. and for any three value, obviously there are three, degree is 3, so there are only 3 roots. So for any 3 values you will have mu z is equal to 0. So for which whatever the value you are putting, when mu z comes as 0, you will consider that value as a root of mu z. So here for this example, alpha square, alpha 10 and alpha 13 gives the value of mu z is equal to 0. So the roots here are alpha square, alpha 10 and alpha 13. So just write it down, the content of this slide. So my mu z is z plus alpha square, z plus alpha 10 and z plus alpha 13. Write this down. So this is the slightly different portion from the error locator polynomial having degree 2. For degree 3, the process is different. So for in exam also, if the theory exam is conducted as per the regular format, you will have to solve this using this method. If you are done with this slide, please let me know. Just write mu z is equal to z plus alpha square and then z plus alpha 10 into z plus alpha 13. This is important. So your roots are alpha square, alpha 10 and alpha 13. So these are the roots, or you can say these are zeros for this example. These are your zeros. Alpha square, alpha 10 and alpha 13. These are the zeros of the given polynomial. Okay. Is this clear? Okay, clear. So this is your, these are your roots alpha 2, alpha 10, alpha 13. So zeros are alpha square, alpha 10, alpha 13. So what are the error locations? Error locations are nothing but what? The inverse of zeros. So what is the inverse of 1 by alpha square? So here again, alpha square inverse means what? It is 1 by alpha square. So replace 1 by alpha 15. Again, you have to follow the same procedure as we have followed in IM inverse part. So 1 by alpha square means what? Replace that 1 by alpha 15. So alpha 15 by alpha 2 is alpha 13. So 1 by alpha 10. What is the inverse of alpha 10? It is 1 by alpha 10. But what is 1? It is alpha 15. So replace 1 by alpha 15. You will get alpha 15 by alpha 10, which is alpha 5. Then alpha 13 inverse. So it is 1 by alpha 13. So instead of 1, it will be alpha 15. So alpha 15 by alpha 13 will be alpha 2. Okay. So these are the error locations where the error is present. So 2, 5 and 13th location, there is error. There is an error at location 2, 5 and 13. I hope this is clear. Is it clear? So alpha 2 inverse, please remember this concept. Alpha square inverse means what? 1 by alpha square. So replace 1 by alpha 15 in each and every part. This is clear? Okay. So shall we move forward? So what is your error locator polynomial or error polynomial? It will be x square, x15, sorry, x5 plus x13. So just add this with the received polynomial. With received code word polynomial, add the received code word polynomial with the error polynomial to get the corrected code word. So what is your corrected code word? What is your received code word? Received code word is nothing but what? X13 plus x10 plus x8 plus x4 plus x plus 1. And you will add these 3 terms to the received code word polynomial to get the corrected code word. So this is your corrected coded polynomial. So 13 will get cancelled. So your highest degree of corrected coded polynomial will be 10. So your first four coefficients of those alpha x terms will be 0 because it is x14, x13, x12, x11. So x10 is present, that's why 1 is present. Then 9 is absent, so 0. Then 8 is present, that's why 1 is there. Then 7 and 6 is absent, so 0 is there. Then 5 4 is present, that's why 1 1 is there. 3 is absent, so 0. And then last three terms are present, that is x square plus x plus 1. So there will be 1 1 1. Okay, I hope this is clear. You can write this down, and if this is clear, please let me know. Correct. So I'll x10 plus x8 plus alpha 5, sorry, plus x5 plus x4 plus x square plus x plus 1. This is correct. And this is your corrected code word vector in terms of only binary values, that is zeros and ones. Okay. If this is clear, please let me know. Okay, if this is clear, just write down this example for homework. I hope you will solve this example. Just try to solve the example. I will give the answers in next session. This similar what you have solved here. Have you written the example? Okay, so we'll get back to the example that you have taken for the homework in last lecture. This is the example. I hope you have written the values of S1, S2, S3, S4. So back to this example, there was some typing mistake here for finding out this mu2 and mu1. I have taken the values from the previous example. So instead of 0 and alpha 7, there is alpha 10 and alpha 3. So if you solve this example, you will get mu2 and mu1 as alpha 10 and alpha 12 for the previous example. In the example which I have given for you homework. So mu2 and mu1 for that example is alpha 10 and alpha 12, and then replacing those values alpha 10 and alpha 12 into the mu z, you will get this mu z of degree 2. And then the regular procedure, this alpha 10 is nothing but what, this is the multiplication of the roots of this mu z, and this alpha 12 is nothing but what, addition of those roots. So alpha 10 means what, you can have these pairs of roots for alpha 10. The multiplication, you can take the multiplication from alpha 10 into alpha 0, alpha 9 into alpha 1, alpha 8 into alpha square. So alpha 7, alpha cube, alpha 6, alpha 4, and alpha 5, alpha 5. But you need to find such pair where the multiplication is alpha 10 and addition is alpha 12. So for this, your pair is alpha 6 and alpha 4. You have solved this. If you have solved this, you can cross verify the answers. So your roots are alpha 6 and alpha 4, where the multiplication is alpha 10 and addition is alpha 12. So you'll just replace these values into this form. So alpha 4 and alpha 6. So you can take the alpha 4 and alpha 6 outside of bracket common. Then so you'll get the these values as your zeros. So what is your first zero? It is 1 by alpha 4. And what is your second zero? It is 1 by alpha 6. So these are the zeros, and the inverse of these zeros means again you will have alpha 4 and alpha 6. So your error locations are 4 and 4th location and 6th location. So E of x is x4 plus x6. So if you add this in R of x, you will get this answer, that is x9 plus x6 plus x5 plus x4 plus x plus 1. So this is your corrected code word. Okay, I'll share this PPT after the completion of RS code. Okay, so in next lecture we will see the, just revise the what is the numerical I have given today for homework, and then we'll start with the RS code in next session. Okay, so if you have any difficulty while solving these examples based on the BCH encoding as well as decoding, please let me know. Okay, if there is any doubt, please ask me. Otherwise, I will end this meeting. So shall I end this meeting? Is it clear? But try to solve this example. Huh? Whatever you have written for the homework, try to solve this example. Have some uh, clear concept at your end, because I think this is different example what we are up to what you are whatever you have seen up to this point. This is different example. Whatever you have taken the for the homework, this is different example. So just solve this example and try to conclude the result at your end. Okay, so I'll share the solution in next session at the starting of next session. So for today, I think this is sufficient. So I'll end this meeting. If you have any doubt, ask me later. I will end this meeting. Okay. Thank you.